In a hangar outside Munich, 1963, West German aviation engineers gathered around a prototype transport aircraft meant to rival America's legendary C-130 Hercules. Years of design work, hundreds of millions of marks invested, and promises of European aviation independence all rested on this aircraft, designated the C-160 Transall. What followed was a decades-long saga of technical compromises, cost overruns, operational limitations, and the humiliating realization that West Germany and France together couldn't match what American engineers had achieved a decade earlier.
The shadow of American superiority. By the late 1950s, the Lockheed C-130 Hercules had established itself as the world's premier tactical transport aircraft. First flown in 1954, the C-130 combined remarkable load capacity with the ability to operate from short, unprepared airstrips, revolutionizing military airlift operations. The United States Air Force ordered hundreds, and allied nations clamored to purchase the aircraft that could deliver troops, equipment, and supplies to forward areas that conventional transport aircraft couldn't reach. West Germany, re-established as a nation and rearmed as part of NATO in the mid-1950s, desperately needed tactical transport aircraft. The reborn Luftwaffe was being equipped primarily with American aircraft, F-86 Sabre fighters, F-104 Starfighter interceptors, and various other types, all purchased through military aid programs or direct purchases. This dependency on American equipment grated on German politicians and military leaders who remembered Germany's aerospace prowess during the war years and sought to rebuild an indigenous aviation industry. The obvious solution was to purchase C-130s from the Americans, as many NATO allies had done. But West German political leadership, particularly Defense Minister Franz Josef Strauss, pushed for a different approach, developing a European transport aircraft that would provide equivalent capabilities while rebuilding German and French aerospace industries and reducing dependence on American technology. We cannot remain perpetually dependent on American generosity for our defense needs, Strauss declared in a 1959 speech. Germany must rebuild its aviation industry, and this requires undertaking our own development programs, not merely purchasing American aircraft forever. This political imperative drove what became the Transall program, a joint German-French effort to develop a tactical transport aircraft. From the beginning, the program was shaped more by political considerations than military requirements or technical realities. Germany and France needed to cooperate to share development costs, but the two nations had different requirements, different industrial capabilities, and decades of mutual distrust to overcome. Colonel Engineer Helmut Schmidt, no relation to the future chancellor, appointed technical director of the German contribution to the Transall program in 1960, recognized immediately that the project faced daunting challenges. A veteran engineer who had worked at Messerschmitt during the war and spent the 1950s working on licensed production of American aircraft, understood both German aviation capabilities and the enormous gap between those capabilities and American standards. The C-130 represents 15 years of American transport aircraft development, Schmidt told his team during initial planning meetings. Lockheed didn't just design an aircraft, they created an integrated system optimized for tactical airlift. Every aspect, the engines, the cargo compartment configuration, the loading systems, the avionics, reflect accumulated experience and sophisticated engineering. We're starting from scratch, trying to match their capabilities with limited budgets and 2 decades of interruption in German aviation development. The Transall design requirements, finalized in 1960, called for an aircraft that could carry 16,000 pounds of cargo, or 93 paratroopers, operate from short, unprepared airstrips, cruise at about 300 miles per hour, and have a range of approximately 1,000 miles with full payload.
These specifications were intentionally chosen to roughly match C-130 capabilities, though careful analysis revealed they were actually somewhat less demanding than what the Hercules achieved.
The compromises began. The design that emerged from German and French collaboration, designated C-160, was superficially similar to the C-130, a high-wing configuration with 4 turboprop engines, a rear loading ramp, and a cargo compartment sized for military equipment. But beneath the surface similarities lay numerous compromises driven by technical limitations and political considerations. The engines selected were Rolls-Royce Tynes, British turboprops producing approximately 6,000 shaft horsepower each, compared to the Allison T56 engines on the C-130, which produced about 4,500 shaft horsepower. The higher power seemed like an advantage, but it masked a critical weakness. The Tyne engines were heavier, consumed more fuel, and were significantly more expensive to operate and maintain than the American engines. "We need the extra power because our aircraft will be heavier than originally planned," explained the chief aerodynamicist Dr. Wolfgang Bauer during a design review in 1962. "We're using aluminum alloys and construction techniques that add weight compared to American methods. The Allison engines would be inadequate for our actual design weight." The weight problem emerged from multiple sources. German and French aluminum alloys, while adequate, weren't optimized for aerospace applications the way American alloys were. Manufacturing processes, riveting, assembly methods, structural design reflected interrupted development and less sophisticated techniques than American industry employed. Quality control wasn't as rigorous, meaning structures had to be built stronger and therefore heavier to compensate for variability in materials and workmanship. The cargo compartment dimensions were another compromise. The C-160's cargo hold was slightly smaller than the C-130's in critical dimensions, limiting what could be carried. American engineers had carefully optimized C-130 dimensions to accommodate standard military vehicles, artillery pieces, and container systems. The C-160's slightly smaller hold meant some items that fit easily in a C-130 required careful positioning or couldn't be carried at all. The loading systems, the ramps, winches, and cargo handling equipment were less sophisticated than American equivalents. The C-130 featured a highly refined cargo loading system with powered rollers and equipment that enabled rapid loading and unloading. The C-160 systems were more basic, requiring more manual labor and more time to accomplish the same tasks. Avionics, the electronic systems for navigation, communication, and flight control, represented perhaps the widest gap between American and European capabilities. The United States had invested heavily in military avionics development through the 1950s, producing systems that were reliable, sophisticated, and increasingly miniaturized. European electronics lagged significantly, with components that were larger, less reliable, and less capable than equivalent American systems. Our avionics suite will provide adequate functionality, but it will be heavier, require more maintenance, and offer fewer capabilities than equivalent American systems. We simply don't have access to the transistor technology and miniaturization techniques that American contractors employ. By 1963, when the first prototype was nearing completion, the C-160 had grown heavier and more expensive than initial projections. The empty weight exceeded 63,000 pounds, nearly 8,000 pounds heavier than a comparable C-130E model. This excess weight reduced payload capacity, shortened range, and required more powerful and more expensive engines to achieve specified performance.
The test program revealed problems. The C-160 first flew on February 25, 1963, from a factory airfield outside Hamburg.
The test flight was brief and cautious, with the aircraft demonstrating basic airworthiness but revealing handling characteristics that concerned test pilots. The aircraft felt heavy and sluggish compared to the C-130, requiring more runway for takeoff and landing and showing less maneuverability in flight. "It flies like a truck," one test pilot commented bluntly after an early flight. "The C-130 feels nimble and responsive despite its size. This feels like wrestling a reluctant elephant into the air. It will do the job, but it's not pleasant to fly." The test program, conducted over 2 years, revealed a litany of problems. The engines, while powerful, proved temperamental and maintenance-intensive. The Rolls-Royce Tynes required frequent inspections and adjustments, with components failing more often than reliability predictions suggested. Engine maintenance consumed twice as many man-hours as comparable American engines, significantly increasing operational costs. The cargo loading system proved problematic during trials with actual military equipment. Items that should have fit based on dimensional specifications had to be carefully positioned to clear the slightly smaller cargo compartment. Loading and unloading took longer than specified, reducing operational efficiency. The powered loading system suffered frequent mechanical failures, sometimes requiring manual loading that was time-consuming and labor-intensive. Short-field performance, one of the C-160's primary design requirements, barely met specifications and only under ideal conditions. The heavier weight meant the aircraft required longer takeoff and landing distances than initially promised. Rough field operations stressed the landing gear and structure, causing premature wear and requiring reinforcement that added yet more weight. The avionics systems showed high failure rates during testing. Navigation equipment malfunctioned frequently, communication radios proved unreliable, and flight instruments needed constant maintenance. These weren't catastrophic failures, but chronic reliability problems that would plague the aircraft throughout its service life. Colonel Schmidt, monitoring the test program with growing concern, prepared a comprehensive technical assessment for ministry officials in early 1965. His report documented the C-160's shortcomings compared to C-130 capabilities and estimated that the aircraft would cost approximately 40% more to operate per flight hour than an equivalent American aircraft while delivering somewhat less capability. "We have created an aircraft that meets basic requirements but falls short of American standards in almost every measurable category," Schmidt wrote. "It is heavier, shorter range, more expensive to operate, and less reliable than the C-130. The French are equally disappointed with the results. We must honestly assess whether continuing production serves our interests or whether purchasing C-130s would better meet our needs." Political pressures override technical reality. Schmidt's assessment reached Franz Josef Strauss and other political leaders at a delicate moment. The Transall program had already consumed hundreds of millions of marks. German and French aerospace companies had invested heavily in production facilities. Employment for thousands of workers depended on the program continuing, and politically, canceling the program would be admitting that European cooperation couldn't match American capabilities, a humiliating acknowledgement that would undermine efforts to build European defense independence. "The technical shortcomings are noted," Strauss replied to Schmidt's report, "but they must be weighed against broader considerations. We cannot perpetually depend on American technology. We must accept some performance compromises to rebuild our industrial capabilities and maintain our technological independence." This political calculus, accepting inferior performance for political and industrial policy reasons, doomed the C-160 to decades of operational mediocrity. Production proceeded, despite the known limitations, with Germany and France each building assembly lines and committing to purchase quotas that would keep factories operating. The first production C-160s entered service with the Luftwaffe in 1968, more than a decade after the C-130 had entered American service. German air crews, many of whom had trained on C-130s or flown with American units, immediately noticed the differences.
The C-160 was adequate for basic transport missions but lacked the versatility, reliability, and performance margins that made the C-130 so effective. Everything takes longer with the C-160, a Luftwaffe transport pilot explained in an interview years later. Loading takes longer because the systems are less sophisticated and less reliable. Flights take longer because the aircraft is slower and has less range, requiring more frequent refueling stops. Maintenance takes longer because components fail more frequently and are harder to access. It does the job, but it's like using a dull tool when you know sharp ones exist. The French experience mirrored Germany's. French Air Force crews found the C-160 acceptable but unexceptional, and France continued to operate older American-designed Nord 2501 transports alongside the Transall because the C-160 couldn't fully replace them. Several nations that had been expected to purchase the C-160 as export customers instead bought C-130s, finding the American aircraft more capable despite higher purchase prices.
The long operational struggle. Through the 1970s and 1980s, the C-160 served with German and French forces in various operations worldwide. It proved adequate for routine cargo transport, could deploy paratroopers competently, and occasionally demonstrated useful capabilities. But it consistently showed limitations compared to the C-130s that other NATO allies operated. During joint NATO exercises, C-160s regularly required more support, more maintenance time, and completed fewer sorties per aircraft than C-130s operating in similar conditions. The operational availability rate, the percentage of aircraft ready for missions at any given time, averaged about 60% for C-160s compared to 75 to 80% for well-maintained C-130s. This meant that to achieve the same operational capability, more C-160s were needed than would be required if the force consisted of C-130s. The cost implications were significant. West Germany had purchased C-160s partly to save money compared to buying American aircraft. But the higher operating costs and lower availability meant that over the aircraft's lifetime, the total cost of ownership actually exceeded what purchasing C-130s would have cost. The political goal of industrial independence had been achieved, but at enormous financial cost. Attempts to upgrade C-160s to match evolving C-130 capabilities consistently failed or were prohibitively expensive. The C-130 underwent continuous improvement throughout its service life, with new engines, improved avionics, structural enhancements, and specialized variants for aerial refueling, gunship operations, electronic warfare, and special operations. The C-160's basic design limitations prevented most equivalent modifications from being feasible or cost-effective. "We're locked into an aircraft that can't grow or adapt," a Luftwaffe logistics officer complained in the 1980s. "The Americans keep improving the C-130, adding new capabilities, fixing problems. We're stuck with an aircraft whose basic design is frozen because we lack the resources to extensively modify it and because the airframe can't accommodate many improvements anyway." By the 1990s, with the Cold War ended and defense budgets under pressure, the limitations of the C-160 became increasingly problematic. German reunification had created new transport requirements, and overseas operations, peacekeeping missions, humanitarian interventions, support for deployed forces demanded capabilities the aging C-160 fleet struggled to provide. Germany began supplementing its C-160 fleet with leased American C-17 Globemaster III transports and eventually purchasing military versions of the Airbus A400M, a new European transport aircraft that, ironically, was designed to finally match capabilities that the C-130 had demonstrated decades earlier. France followed a similar path, recognizing that the C-160 no longer met modern requirements.
The failed legacy. The C-160 Transall program,
viewed from the perspective of the 21st century, represents a case study in how political considerations can produce technically inferior solutions at enormous cost. The aircraft served for nearly 50 years, providing adequate transport capability to German and French forces, but it never matched the C-130's performance, reliability, versatility, or cost-effectiveness. Total production reached only 214 aircraft, a fraction of the more than 2,500 C-130s produced. This limited production run meant that development costs were spread over fewer aircraft, making each C-160 more expensive. It also meant that the industrial benefits that justified the program, sustained employment, technology development, industrial capability, were achieved at far higher cost per job and per unit of capability than purchasing American aircraft would have incurred. The broader strategic objective, reducing European dependence on American military technology, was not achieved. Despite producing the C-160, both Germany and France continued to rely heavily on American aircraft for much of their military aviation needs. The Transall program didn't create the foundation for an independent European aerospace industry, but instead consumed resources that might have been better invested in areas where European industry could be more competitive. Colonel Schmidt, who retired from service in 1975, lived long enough to see the C-160 phase out of service in the 2020s, replaced by more capable aircraft. In interviews late in life, he expressed frustration with the political pressures that had forced continuation of a program that technical assessment showed was flawed from the beginning. We knew in 1965 that the aircraft was inferior to the C-130, Schmidt said in a 1998 interview. Every technical assessment confirmed it. But political leaders decided that industrial policy and European prestige mattered more than military effectiveness or financial efficiency. So we built an inferior aircraft for 50 years, spending billions more than necessary, all to avoid admitting that the Americans had built a better aircraft that we couldn't match. The C-130 Hercules, which West German politicians and engineers attempted to rival with the C-160, continues flying today, more than 70 years after its first flight, and likely to continue for decades more. Continuous improvements, structural life extension programs, and new production variants keep the basic design relevant despite its age. The most recent C-130J Super Hercules variant, introduced in the 1990s, features completely new engines, avionics, and systems, while retaining the basic airframe configuration that proved so successful in 1954. The contrast could not be starker. The American aircraft that inspired the C-160 remains in production and frontline service globally, while the European aircraft meant to match it has been retired after a mediocre career characterized by limitations, compromises, and disappointed expectations.
The lessons ignored. The C-160 Transall story offers clear lessons about military aviation development, but they are lessons that seem to be repeatedly forgotten or ignored. Political prestige and industrial policy are poor reasons to develop military aircraft. The primary criteria should be military effectiveness, operational suitability, and cost-effectiveness over the system's lifetime. Attempting to match mature, successful designs without the underlying industrial capabilities and accumulated expertise that made those designs successful is likely to produce inferior results at higher costs. The Americans who designed the C-130, built on decades of transport aircraft experience, had access to advanced materials and manufacturing processes, and could draw on the expertise of the world's most sophisticated aerospace industry. West Germany and France in 1960 lacked all these advantages, but assumed they could compensate through determination and cooperation. Joint international development programs, while politically attractive for sharing costs and building cooperation, introduce complexity and compromise that often result in systems that don't fully satisfy any participant's requirements. The C-160 was designed by committee, with German and French requirements sometimes conflicting and political considerations forcing technical compromises that weakened the final product. Yet despite these clear lessons, European nations repeated the same pattern with the Airbus A400M transport aircraft developed in the 2000s. That program experienced massive cost overruns, decade-long delays, technical problems, and produced an aircraft that, while more capable than the C-160, still doesn't match the capabilities of American competitors in several important categories. The political imperative to maintain European aerospace independence continues to drive programs that cost more and deliver less than simply purchasing American systems. The C-160 Transall ultimately served adequately in the limited role it was capable of filling, but it represented a massive waste of resources and a missed opportunity. The hundreds of millions of marks invested in development and the billions spent on production and lifetime operations bought an aircraft inferior to what could have been purchased off the shelf from the Americans. That money could have been invested in areas where European industry had competitive advantages or in military capabilities where no American alternative existed. The aircraft's retirement in the 2020s, nearly 60 years after its first flight, ended a chapter in European military aviation that demonstrated the costs of allowing political considerations to override technical and economic reality. The C-160 Transall was not a complete failure. It served honorably, if unspectacularly, but it was a compromised solution to a problem that better alternatives already existed for. It stands as a reminder that national pride and industrial policy are poor substitutes for technical excellence, and that sometimes purchasing the best available solution from whoever produces it serves national interests better than insisting on domestic alternatives, regardless of cost or capability.
If you enjoyed the video, don't forget to subscribe to the channel and hit the like button so we can keep creating more content.